Welcome to your first video for Unit 4 on inequalities. In this video, we're going to translate mathematical words into equalities. So, we will translate inequalities in word form to symbolic form. The table below shows 6 ways we compare expressions using their corresponding language and symbolic notation. We are already familiar with the comparatives equal and not equal to. The other 4 comparatives use the relationship less than or greater than and the possibility of equality. So let's look at this chart, and this chart is in your media lesson packet. We have equal to and not equal to, which we've discussed before. And now we have a new phrase called is less than. So 2 is less than 3. And this means on the number line, 2 is located to the left of 3 on the number line. In algebraic terms, we may say x is less than 3. We also have is less than or equal to, so 1 is less than or equal to 6, or x is less than or equal to 6. So notice in the algebraic form, it would be a true inequality if we replaced x with 6 here, because x can be less than 6 or equal to 6. Where in the previous case, we have that x is less than 3. So let's just note that a term we frequently use when we're talking about when something is less than or greater than but cannot equal to is a strict inequality. Okay. So then we also have is greater than or equal to. Okay. So now something you may have noticed is that we've used terms like less than or greater than in previous sections to describe addition and subtraction. So looking at this chart, I want you to notice the difference between the first 2 rows. When we simply stated less than, like 1 less than 5, that meant to subtract 1 from 5 or 5 minus 1. However, when we're talking about a comparative, a comparison between 2 numbers, we use the word is less than as opposed to just less than. And notice we may say 2 greater than 8, that would imply addition. Is greater than implies a comparison. So just like in a lot of examples when we talked about equality, we said 5 is equal to 3 or 5 is the same as 3. The verb is makes it not only a phrase but a sentence, and it shows that we're comparing 2 different sets of numbers or algebraic expressions. So make sure you keep your eye out for the word is to know you're using a comparison. So let's get started. Use the information for translating mathematical language into solid symbolic forms from the previous page to write the following statements as inequalities. Okay, so let's read the first one. 4 less than x is greater than 3. Okay. So notice this is very similar to the equations that we worked with. An equation might have said 4 less than x is 3, but now notice we have the is greater than. So we're going to start these by locating the comparative. We'll look for the word is, and in this case we have is greater than. Okay. Then we're going to have the left-hand side of the inequality and the right-hand side of the inequality. So on the left-hand side, notice it says 4 less than x. Okay, there's no is here, so 4 less than x means take x and subtract 4. Now we have is greater than, so this is the greater than symbol, and the quantity 3 is on the right-hand side of the inequality. So our symbolic inequality, we will write x minus 4 is greater than 3. Now I want to draw your attention to something. We're actually going to write 2 symbolic inequalities for all of these. This is the direct translation of this phrase, but I want you to be aware that there is an equivalent phrase that we can write with a less than symbol. Now inequalities, unlike equations, I can't just change this symbol to a less than symbol and move everything down. So remember, if we had x equals 3, we could also say 3 equals x, and this wasn't problematic. This property in mathematics is called symmetry. This does not apply to inequalities if we know 2 is less than 3. But now if we reverse the 3 and the 2, we have to say 3 is greater than 2. Okay? So you'll be working with many problems where when we have a variable type, like we'll say we have x is less than 3, you may solve and get a result that says 3 is greater than x. And these are equivalent statements even though they're written in a different form. So we're going to practice writing them in both ways. So the original is x minus 4 is greater than 3. And we can also say 3 is less than x minus 4. Okay. Another way to focus in on this symbol besides the words, and the words are very important, but you may want to notice that we'll work with 2 and 3 here. If you look at the inequality sign, you can think of, we have here there's 1 point and here there's 2 points. Okay? And some teacher, probably in elementary school, that's supposed to be teeth, sorry, I'm not an artist, said that this is a hungry alligator. The alligator always wants to eat the bigger number because it's hungry. So if you think of this as a mouth, the larger open part will always be pointing towards the larger number. Okay? So we can read this as 2 is less than 3, and simultaneously, without rewriting it, I'd like you to become comfortable with saying that this also means 3 is greater than 2. Okay? Let's look at the next one. 3 times the difference between a number and 5 is less than 12. So I'm going to find the is, and we have an is less than. Okay? So this is the left-hand side of the inequality, and this is the right. So on the left-hand side we have, let's map this out a little bit more, 3 times, we have the difference between, and here's the end, and you're finding the difference between a number and 5. Okay? And then we're going to take 3 times that difference. So remember that means to find 3 times the difference, we need to put the difference in parentheses. So we multiply the whole difference by the 3. So a number and 5, I'm going to use n for the number, and 5. And then we have is less than 12. So our symbolic inequality is 3 times n minus 5 is less than 12. And if we want to write this as a greater than statement, we would say 12 is greater than 3 times the difference between n and 5. Let's look at the next one. 6 is greater than, so we have that is greater than right at the beginning. And then notice it also says or equal to, so I'm going to highlight that. So this is not a strict inequality. These were both strict because we didn't include the endpoint. We don't have an equal sign on the bottom. And the difference between 3 times x and 5. So the left-hand side is easy. We have 6. Let's put our greater than or equal to symbol. Now the right-hand side, we need to look at a difference between, oops, that was a pencil, not a highlighter. The difference between, here's the end, and we're finding the difference between 3 times x and 5. So that means we'll start with 3x and subtract 5. So our inequality is 6 is greater than or equal to 3x minus 5. Again, we could reverse this direction, but we'd have to reverse the inequality symbol. So this is equivalent to 3x minus 5 is less than or equal to 6. Let's look at the next one. The product of 8 and a number is less than or equal to twice the number. Okay? So here's our comparative. This is our left-hand side. This is our right-hand side. The left-hand side is the product of, here's my end, it's 8 and a number, and the right-hand side is just twice a number or 2 times a number. Okay? So the product of 8 and a number is 8 times n, or 8n, is less than or equal to twice the number. So 8n less than or equal to 2n in symbolic form. And if we want to rewrite this as greater than, it would be 2n is greater than or equal to 8n. And looking at the last one, 3 more than x is, so I'm going to start highlighting, is less than, so that's a strict inequality, there's no or equals to, the quotient of x and 7. So looking at the right-hand side, we have the quotient of, and there's the end. So the two values we're finding the quotient of are x and 7. On the right-hand side, we have 3 more than x, so that means we're going to add 3 onto x. So 3 more than x is x plus 3 is less than the quotient of x and 7. So x plus 3 is less than x over 7. And to write an equivalent inequality using a greater than symbol, the big part is pointing towards x over 7, so I'll reverse it. X over 7 is greater than x plus 3. In the next video, we're going to translate some contextual problems into inequalities.